morning all. My name is B. Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My topic is zooming and shrinking in digital images. So, before going to this topic, zooming and shrinking, what is the definition of zooming and what is the definition of shrinkage and what is the related to the digital images? So, zooming simply means enlarging a picture in a sense that the details in the image become more visible and clear. Digital zoom is basically image processing within a camera. During a digital zoom, the center of the image is magnified and the edges of the picture got cropped out. So that is the meaning of zooming. Suppose zooming means we are enlarging the image. So we are enlarging the more pixels. Suppose my pixel is a 56 into 56. Suppose so if I'm enlarging the image means we are more enlarging the pixels. So the pixel size also increasing, enlarging the pixels. The pixel size are very increasing. So what is the use of increasing the pixels? So when we are increasing the pixels means we are applying the zooming. So what is the need of zooming means suppose we have to more clarity about the picture. Some small elements are there in the picture. So we have to recognize that one. So we are applying the zoom. So that means enlarging the picture. Then we are easily find out that one. So that is the advantage of zooming. So it is simply means enlarging a picture in a sense that the details in become more visible and clear. Digital zoom is basically image processing within a camera. So in the camera we have two options are there. Suppose I'm taking normal image, then I'm going for applying the zooming on the original image. So that is one technique. Otherwise I'm applying the zoom in the camera. I'm applying the zooming in the sensors or digital camera. Then I will take the picture. That is another technique. There are two techniques of that in the mobile, in the camera we are applying the zooming, or after getting the picture in that image we are applying the zooming. That is the advantages. There is a two steps for zooming, and another one is a shrinkage. So shrinking in the other hand involves reduction of pixels. It is exactly opposite to the zooming. Zooming is exactly opposite to the shrinkage. So zooming means enlarging. Shrinkage means we are reducing the pixels. Here increasing the pixels. Here reducing the pixels. So the other hand involves a reduction of pixels, and it means loss of irrevelation formation in the scale algorithms to find the right pixels of the through array. So reduction of pixel size. Okay, zoom out, zoom in, zoom out like this. Okay, if I'm applying the zoom in means zooming, zoom out means going for the shrinkage. Okay, reducing the pixels. So what is the advantage of shrinkage means we are reducing the pixels. The pixel size is reduced with the help of shrinkage. And scaling is another major role in zooming and shrinkage. So scaling is used for shrinking or zooming of an image. So what is the advantage of major role of the scaling in the shrinking and zooming of the image? So suppose I'm taking upsampling, also known as a oversampling. So when I'm going for the sampling, that is a oversampling, that is called upsampling. So in an image, oversampling means using a high resolution image sensor is compared to the camera output image resolution. So when I'm applying the zooming, I need a high resolution of the image sensor. So then I'm going for the oversampling of that one. So oversampling means sampling technology is indirectly helpful for the zooming method. So it is a high resolution on the camera output. So one of the oversampling applications in an image processing is known as zooming. So when applying the zooming, when I'm applying the zooming in the image, so the oversampling application in an image is processing is known as zooming. So zooming oversampling means higher resolutions, going for the higher resolutions. Suppose I'm taking 3x3 with a high resolution. So I'm applying the zooming for that one. So zooming always you have to change the size of the content so that it is visible in the viewpoint. So here zooming is means enlarging. Shrinking means we are going for the reduction of pixels. So both of the zooming and shrinkage, we are applying the scaling function. So what is the scaling means? We are going for the oversampling or upsampling. So when applying the oversampling or upsampling, we are going for the zooming or shrinkage of that image. So the black pixels represent the empty spaces where interpolation is needed and the complete picture of the result of the nearest neighbor interpolation. So if I am taking the black and white picture, when I am applying the black and white picture, so the black pixels represents empty spaces where interpolation is needed and the complete picture is the result of nearest neighbor interpolation. And the scaling algorithm, already we discussed, scaling is a oversampling. So scaling algorithm is using for zooming and shrinkage process. So scaling algorithm is to find appropriate spot to put the empty spaces inside the original image and to fill all those spaces with linear colors. There are many methods of gray levels assignments for examples. So here I am taking one example, zooming. It is increasing the resolution of the size and an image. So you can see here, suppose here so many pixels are there, 1, 2, 3, 4, 5, 6. So 6 into 5 pixels. So here only 2 by 3 is there. So when applying the 2 by 3, if applying the zooming, then it is converted to 6 by 5 pixels. So less number of pixels are converted to more number of pixels. So shrinkage means more number of pixels are converted to the less number of pixels. So zooming is exactly opposite to the shrinkage and shrinkage is opposite to the zooming. So what is the definition means? Zooming is the increasing the resolution or size of the image. Shrinkage is the decreasing the resolution or size of the image. That is a shrinkage. So the pixel replication. What is the pixel replication? The interpolated pixel in the enlarged image is set to the gray level of its nearest pixel in the original image. That is a pixel replication. Next one is a bilinear interpolation. Interpolated pixel in the enlarged image is set to the average its or nearest pixels in the original image. Suppose I am taking one image. So what is the pixel replication going for? It is the interpolated pixel in the enlarged image is set to the gray level of its nearest pixel into the original image. Suppose here what is the original image? It is a original image. Okay, it is a original one. So when we are enlarging the image is set to the gray level of its nearest pixels. So here how many gray levels are there? Here only 6 are there. But here 6 gray levels are there. But what are the remaining? So we are applying some gray levels to that one. So these are the pixel replications. So interpolated pixel in the enlarged image is set to the gray level of its nearest pixel in the original image. That is a pixel replication. Next, bilinear interpolation. So each pixel, how many are there? So here bilinear interpolation, the interpolated pixel in the enlarged image is set to the average its 4 nearest pixels in the original image. So it is one side, another side, another side, another side. How many are there? 4 sides. So bilinear interpolation, interpolated pixel in the enlarged image is set to the average its 4 nearest pixels in the original image. So what is the original image? What are the 4 sides are there? I am taking the average of the original 4 sides. Okay, that is the bilinear interpolation. So pixel replication, bilinear interpolation are taking from the original image, and we are taking the average of the original image, and we are forming the gray levels from the original. So suppose it is one example of zooming and shrinkage. Here top row images are zoomed from 128 to 64. Okay, here one image 128, another one is a 64, 32 and 1024 pixels. Using nearest neighbor gray level interpolation, the bottom row same sequence but using bilinear interpolation. So here 128, 64 and 32 size pixels are there. Here 128 into 128, 64 into 64, 32 into 32 pixels are there. So when we are reducing the pixel size, it is going as a blurring. So it is showing as a images. So these are the pixels. So it is clearly showing visible the pixels. So in this using the nearest neighbor gray level interpolation, the bottom sequence by using bilinear interpolation. So here only I am reducing the size 128 to 64, 64 to 32 pixels. So here I'm reduced the pixels. So what was happened? It is going as a some blurring image, or it is showing as a what are the pixels? It is showing clarity. What are the pixels are there? How many pixels are there? Each pixel, what is the color it is showing? But it's a bottom of that one. It is a nearest neighbor level interpolation. The bottom row same sequence but using bilinear interpolation. Here I'm using bilinear interpolation. So it is showing as a pixels but it is going as a blurred image. So we are applied both the techniques, but which one is the better? So that is it. Last one is a blurred, means we are not recognizing that image. Okay, and shrinkage by an integer number can be done by deleting some of the rows and columns of the image. So when I am going for the shrinkage, see here what is the size here, 56 into 56 example, but here I am taking 2 by 2 example. So what are the gaps are there now? So I no need of these gaps, so we have to reduce the size. We are reducing these gaps. Okay, so then we are reducing the gaps means we are reducing the size. So shrinkage by an integer number can be done by deleting some of the rows and columns of the image. So it is possible to remove rows and columns. Possible to remove rows and columns in the shrinkage. But shrinkage by a non-integer factor can be done as the inverse of zooming. Okay, when applying the inverse of zooming, that is called shrinkage. So shrinkage by a non-integer factor can be done as the inverse of zooming. When we are applying the inverse to the zooming, that is a shrinkage with the non-integer factor. So what is a major function of shrinkage means? We are removing the rows and columns to reduce the size. Reduce size is the important for shrinkage. So shrinkage by an integer number can be done by deleting some of the rows and the columns. So the zoom is done so that the position at which the user applies the operation is kept fixed. So if I'm applying the zooming, so if example I'm taking one image, the zoom is done so that the position at which the user applies is the operation is kept fixed. So the operation is kept fixed of the image with pixels. So zooming may be viewed as a oversampling. It is a scaling of an image area A of W into H pixels by a factor S while maintaining spatial resolution, that is output of SW into SH pixels. Suppose I'm taking, so x-axis, y-axis, 2 dimension. So when I'm going for the zooming, so I need a oversampling, increasing the resolutions. Oversampling means increasing the resolutions. So if I'm applying the scaling function of the image, the area A is equal to W into H. So rows into columns by a factor S while maintaining spatial resolution. That is output is a SW into SH. So I'm taking it is a S and it is a W. S into W, area A equal to total S into W, but I want to increase the resolution. if I want to increase the resolution, what is happening means, increase the resolution means I am applying the SW into SH, SW into SH. So why? Because I'm increasing the resolution values. Okay. So zooming, increasing the number of pixels in an image so that the image appears larger. Zooming requires two steps. So when I'm applying the zooming of the image, what will happen? The resolution is increased. Resolution is increased. So the resolution is increased. That appears as a large. Zooming requires two steps. First one is a creation of new pixel locations and assignment of gray level to those new locations. Okay. First one is a creation of new pixel location. So when I'm applying the original image I'm applying to the zooming method. So it is the input. I'm applying the zooming for that one. So what is the output image? So the output image, increasing the number of pixels in an image, the image appears large. Zooming requires two steps. So what is output? Means enlarging of the image. So what is happening means new pixel locations. So new pixel. What is the old one? Suppose 3 into 3 is there. But when I am applying the zooming, it is converted to the 5 into 5. It is applied to the 5 into 5 pixels. So enlarged. I am enlarging the original image. So the new pixel locations will become and assigning the gray level to those new locations. So we are assigning here 3 by 3 is there, but here 5 by 5 is there. So 3 by 3 equal to 9 pixels are there. But here 5 by 5 means 25 pixels are there. Here only 9 gray levels are required, but here 25 gray levels are required. So are we increasing the gray levels? Yes, we have to increase in the gray levels. Then only the zooming process will become. So that is a scaling function. And the nearest neighbor interpolation. So nearest neighbor interpolation. There are 4 neighbors are there. Here I am taking 4 neighbors. So nearest neighbor interpolation, bilinear interpolation, k times zooming image interpolation used to change x and y dimensions, and nearest neighbor interpolation with zero order hold is performed by repeating pixel values, thus creating checkboard effect. So what are the techniques are for the zooming? Means first one is a nearest neighbor interpolation. Suppose I am taking one image. What are the neighborings of that one? So these are the 4 neighbors are there. Neighboring interpolation. I am selecting the neighbor interpolation. Next I am going for the bilinear interpolation. So after selecting that one, going for the bilinear interpolation. Next, k times zooming image interpolation. Suppose the original image is 3 by 3. I want 6 by 6. So is it changed as k times? Means here 2 times increased. Another one is I need 9 by 9. So 3 times increased. So the k times zooming interpolation is used to change the x and y dimensions of an image. So the nearest neighbor interpolation, zero order hold, is performed by repeating pixels values, thus creating checkboard effect. So when I am increasing the pixels means the gray level was also increasing. So the nearest neighbor interpolation means zero order hold is performed by repeating pixel values. So if I am increasing the values means pixels means we are increasing the pixel values means increasing the gray level values. Okay, the repeating values we have to take to creating the new pixel. Okay, that it is creating the checkboard effect. And what is the k times zooming? So when we are taking the 2 adjacent pixels as you did in the zooming twice, so k dimension means x axis and y axis with the image. So I am taking 2 dimension x and y axis. Then we have to subtract the smaller from the greater one. We can call as the output. Okay, what is the output of the image of k times means we are subtracting the smaller from the greater and dividing the output with zooming factor. So after getting the greater minus smaller, what is the value we have? That is the output value. So we are dividing that output value with zooming factor k. Okay, output by k. Okay, so that is a zooming. Now we have to add the result to the smaller value, put the result between those two values. So add the value of output. What is the value of output? Again the value is just to put in the place. It again needs to do the previous putted value. You have to do in the till value of the place k minus 1 values in it. Repeat the same step till the rows and columns and we can get zoomed images. So output equal to some output I am getting 5 by 4. So next output value 5 by k value equal to 3, 5 by 2, 5 by 1 like this. So I am changing the k values. Why? Because I am going for the interpolation process. Okay, scaling factor. So I needed different values. Suppose here only 6 pixels are there, but here so many pixels are there. So many pixels are means we have to create some intensity values. So how we are creating the intensity values? So with the help of checkbox, I am applying the intensity values. So like this, I am applying the intensity values. So we are changing the intensity values. Here I am k equal to 5. Here k minus 1 values 4, like 3, 2, 1. So repeating the same with rows and columns. So with how we are means till we are changing the rows and columns, and we can getting the zoomed image. That is a technique. And row wise zooming take as the first 2 adjacent pixels. So I am taking as a row wise. Here k times are there. So how we are taking means rows and columns method. So first I am taking the rows, after then going for the columns. So how we are changing the rows and we are changing the columns. So row wise zooming. So here it is a 3 by 3, but here I am taking as a 6 by 6. So are we changed rows and columns? Yes, 3 is changed to 6, and here the 3 is changed to 6. So rows and columns I changed. So how we are changing the rows and columns? So first one, rows wise zooming. To take the first 2 adjacent pixels, which are 15 and 30. I am taking one example here, 15 and 30. So subtracting 15 from 30. So what is happening? So I am taking 2 values, x and y axis, 30 and 15. 30 minus 15 equal to 15. Dividing the 15 by k value. So here k equal to 3 I am taking. So 15 by 3 means I am taking is a 5. So we can call as a output value equal to 5. Add output value to the lower number. So 15 plus what is the OP value. So 15 plus 5. Output value equal to 15 here. Output value equal to, so OP equal to 15. After the result dividing with 15 with 3. So that is a 5. 15 plus 5 equal to 20. Add OP to 20 again. So 20 plus 5, 25. So we can 2 times of the, because we have to insert k minus 1 values. Now repeat these steps for the 2 adjacent pixels. So I completed for 2 adjacent. After then you can apply for another 2 adjacent pixels. So inserting the values, we have to inserting values ascending order. So remains it is symmetric between them. So what is the rows? So rows in the zooming as a adjacent of 2 pixels. 2 adjacent value I am taking x and y, which are 15 and 30 values. So it is a 30. Suppose here 15 is there. So rows with columns 15 and 30. Subtract 30 minus 15. So 15 is there. Dividing with k value. So what is a k value here? So k value I am taking as a 3. So 15 by 3 is equal to 5. So what is a 5 value means after subtracting and dividing the value is 5. So this we can call as a OP. So add OP to the lower number of values. So 15 plus what is the lower number of value here? I am getting 5. So 15 plus 5 equal to 20. Add OP to the 20. So the OP value is already we are getting 20. Again 20 plus 20 again. So 20 plus 5. So what is the value? Output value equal to 5. So OP value equal to 20. OP plus 5 equal to 25. So 2 times because we have to k minus 1 values. Another 2 adjacent you can do again. Okay, that is a value for inserting and sorting, inserted ascending order. The remains is the symmetric between them. And column wise zooming. We are completed row wise. After then we are going for the column wise. The same procedure has to be performed in the column wise also. How? What is the same procedure? Same procedure as columns, as same procedure as rows. So then the same procedure has to be performed for the column wise as well as in the rows. The procedure include taking the two adjacent pixel values and then subtracting them smaller from the bigger one. So then after we have dividing by the k. So what is the subtracting from bigger to smaller? What is the value is there? That value I am dividing with k, and the value of the stores, the value is with op, output value. Add op to the smaller one, and then again add op to the value of that come first addition of the op. So then we are inserting the new values here. We got the after that one. What are the pixel values are there? Intensity values are there. 15 to 30. So here where there are less number of pixel values are there, here we are changing to increasing the pixel values. How means applying the zooming technology, zooming with the scaling function, and we are applying the oversampling with increasing the values. So there are so many types of digital image fundamentals are there. Elements of visual perception, image sensing and acquisition, sampling and quantization, representing digital images, relationship between the pixels, spatial and gray levels are there. So before they are going to this one, zooming, and we have discussed zooming and shrinking. So why I am applying the zooming and shrinking of that means, zooming means enlarging a picture and shrinking means we are reducing the pixels. So here sampling and quantization also a major role for applying the zooming and shrinking. So that is the reason we have to discuss sampling and quantization also. So here I am applying the scaling function or oversampling function for the higher resolutions to increasing the zooming. So increasing the resolution or pixels. So the black pixels I am representing as an oversampling. So zooming increasing the resolution and shrinkage is decreasing the resolution. So here reduced image increasing the pixels, reduced less number of pixels are there converted to the more number of pixels. Here more number of pixels are converted to the less number of pixels. Okay. So shrinkage is the inversely proportional to the zooming method. So pixel replication, interpolated pixel in the enlarging image is set to the gray level of its nearest pixel in the original image, and bilinear interpolation is the interpolated pixel in the enlarged image is set to the average of the 4 nearest pixels in the original image. Why I am taking 4 nearest means, so it is the one side, upper side and down side. So 4 nearest pixels in the original image. So it is a 128 into 128 converted to the 64 into 64, then 32 into 32. It is one method, and downside another method is a bilinear interpolation method. So in the bilinear interpolation, if we are decreasing the values, then it is showing as a blurred image. So shrinking is the integer number can be done by deleting some of the rows and columns of the image, and the shrinking is a non-integer factor. It can be done as the inverse of the zooming. So shrinking is an integer number can be done by deleting some of the rows and columns of the image, and the shrinkage is a non-integer factor. Okay. So here zooming is done to the position in which the user applies to the operation is kept fixed. So when I am applying the oversampling, the means rows and column values will be changed. Actually, the original is a W into H pixels. The original is a W into H pixels. Here W into H, but I want to increase the pixels. What will happen means SW into SH means I am increasing the pixel values. So actually W into H, but when I am applying the zooming means oversampling, SW into SH pixels means more number of pixels. Okay, and this W into H is a 2 by 2 example, but it is converted to the 4 by 4. So are we changed the pixels? Yes, it was changed. It is called new pixel location. Okay, we are changing, we are saving in the new pixel relocation. Relocation with new pixel locations, and it is a assignment of gray level to those new locations. So here 2 by 2 are there, the intensity values are 4, but here 4 into 4 means how many are there? 16 are there. So we have to apply 16 intensity values or 16 gray levels we have to apply for the new location. Old one is a 4 intensity values or gray levels, but it is changed to SW into SH, means 4 into 4 means 16. So 16 intensity values we have to give, that is a new pixels. And it is a nearest neighbor interpolation, bilinear interpolation, k times zooming. K times zooming means we are increasing rows and columns. We are changing the rows and columns. That is a k times. And nearest neighbor interpolation means, nearest means four nearest values are there. Left, right, top, bottom. Okay. So 4 nearest values are there. So nearest neighbors interpolation, 0 or hold, is performed by repeating pixel values, thus creating checkboard effect. So k times means we are adjusting to adjacent pixel we are taking, that is row and column, and we have to take the output values with the zooming factor. Okay, it is a row wise zooming. So row wise zooming means we have to take row wise columns and 15. Suppose I am taking 15 by 30 size. Okay, so 15 by 30 means I am taking 30 minus 15. 15 dividing the 15 with k factor. What is q factor here means 5 is there. So 3, I am taking example 3. So 15 by 3 is equal to 5. So 15 output value equal to 15. The factor is 5, 20. Add OP to 20. So what is our OP value here? 20. Already we getting the value is 20. So 20 plus 5 equal to 25. So k minus 1 value is next nearest value. So 2 adjacent means k minus 1. Next 2 adjacent means k and k minus 1. So like this 4 adjacent and 2 adjacent pixels are there. It is a column, same process as a rows we are taking here. And digital image fundamentals are the major role. So here when I am going for the zooming, and the shrinkage, we are applying the sampling. Sampling technique or oversampling. So zooming and shrinking process, we are applying the sampling technique, that is a oversampling technique. So sampling and quantization is the major role for the zooming and shrinking, and spatial and gray level, and relationship between the pixels, and representing as a digital images. So with the knowledge of sampling and quantization, we understand representing of the digital images and the relationship between the pixels, and the spatial and gray level resolutions we are getting easily. So what are the gray levels? In that zooming and shrinking, we are increasing the gray levels or intensity values. So what are the gray level resolution? So gray level resolution means, suppose why we are going for the means oversampling means increase gray levels. So how we are increasing the gray levels from the original? So gray level resolution is found of the y-axis of the signal, that is the quantization. X-axis is the sampling. So here I am taking, it is the input signal, okay, continuous wave converted to the discrete system with the sampling and quantization. So I am taking sampling as a x-axis and quantization in the form of y-axis. Okay, here I am taking sampling and y-axis is the quantization. So sampling is a x-axis, I am taking coordinate, y-axis coordinate is a quantization. So why I am taking this sampling and quantization means we are forming the gray levels or we are increasing the gray levels. These are more helpful to oversampling process for the zooming and shrinking. So this means that digitization of the gray level resolution of the image is done with quantization. So after the completion of quantization process, what are the values are there? Those are the digitization. So digital images with the level of resolution or with gray level resolution. So digitizing of a signal after the completion of sampling and quantization process, what is the output? And that is a digitized input output signal. Suppose I'm taking one example. It is a sampling of a signal. So x-axis is a sampling with a time. Y-axis is a quantization or voltage or amplitude. So x-axis, suppose I'm taking, these are the samples, TS, 2TS, 3TS, 4TS, like this. So these are the samples with according with time. Why? Because x-axis I'm taking as a time. So that is the reason I'm taking TS sample, 2TS sample, 3TS sample, 4TS, like this. So 5TS, 6TS, 7TS, 8TS, 9TS. Total how many are there? Number of NTS. Suppose I'm taking NTS at x-axis. So what is a y-axis means? Voltage or amplitude. What is the amplitude levels? I am taking as a y-axis. So x-axis is a sampling, y-axis is a quantization process. So sampling with related to the digital images, the concept of sampling is directly related to the zooming. So when I'm taking x and y axis of the image, the concept of sampling is directly related to the zooming process. Okay, already we discussing our topic is zooming and shrinking. Okay, so when I applying the zooming, it is directly related to the sampling. But here I'm taking sampling is a x-axis according with time. So oversampling can also be called as a zooming. So already we discussed when I'm going for the zooming, I need a oversampling. So that is the reason I'm taking oversampling. Can be also for the zooming. So when I'm taking the sampling with NTS seconds, when I'm going for the oversampling method for the zooming. If I don't want any zooming, I don't go for the oversampling method. So the digitization is a signal does not end at sampling 2. There is another step involved which is known as the quantization. So sampling is not the end of the process. When we are finishing the quantization, then only we are completing the quantization. Okay. So that is the digitization and sampling of the quantization levels. Okay. So quantization, what is a quantization? Is opposite to the sampling and it is done by y-axis. Already we know that x-axis is a sampling, y-axis is a quantization. So quantization is opposite to the sampling. It is done on the y-axis. When you are quantizing of the image, we are actually dividing a signal into the quanta, means partitions, number of partitions. In the sampling, we are taking number of samples. In the quantization, we are taking number of quantas or partitions. So at the x-axis of the signal, the coordinate values are at the y-axis. We have amplitude. So already told y-axis is a voltage or amplitude. So x-axis is the signal, the coordinate values, and the y-axis is the amplitude, okay, or voltage. So the digitization of the amplitude is known as the quantization. When I'm going for the y-axis, the digitization of the amplitude levels, that is a quantization. So we are converting to the quantas or partitions with the amplitude. X-axis means we are changing the time slots, sampling. Number of time slots are converted to the number of samples. It is one example for x-axis and y-axis. Okay, so the quantization levels I'm taking as a 5 different levels I'm taking. So what are the 5 different means? If I'm taking the black and white, the more or less are same colors of the gray. Now we have to make the quality of the image more better. There is one thing we can do. So if I'm taking the color or black and white, so what we are choosing the color image or black and white, then only we are going for the gray levels. The gray levels will be changed. So if I'm taking the color, there are different gray levels. If I'm taking the black and white, there are the different gray levels are there. So what is we are choosing? So there are 5 different gray levels are there. So some gray levels are for color and colors. Some gray levels are for black and white image. So we have to increasing the levels or gray levels resolution up. Increasing this 256 means we have to grayscale image. We have black and white also. We are increasing with a simple. So here I am taking 256 with 5 quantization levels. L equal to 2 power k. 2 power. What is the k value means? Here I am taking as a 5 quantization levels is 256. So L equal to 256 pixels. Okay. Yeah, so if in the case of I know the 256 value, if I know the 256 value, L equal to 2 power k, then k equal to log 2 log L base 2. I'm applying the L value here 256. So k equal to log 2 base 256. So log 2. So if I'm taking 2 power 8 means 8 levels are there or 8 bits. 8 bits may or 8 BPP bits per pixel. So input is a 256, output are the 8 BPP pixels. Okay, if I'm taking one example, it is a 256 gray level and it is a 128 gray level, 64, 32. There is no change in the gray levels. Okay, so two element factors are there. That is the physical device means sensitive to the energy radiated by the object we wish to image, and the second one is a digitizer device to converting the output of the physical sensing device into the digital form. So first way and two ways are there to the acquisition of digital images. The first is the physical device that sensitive to the energy radiated by the object we wish to image, or sensor means input, that is a camera. We are changing in the camera through the camera. The second called a digitizer, a device for converting the output of the physical sensing device into digital form. Okay, that is the digital. So analog input is a analog, but I'm applying the camera. Output is a digital. Okay, that is a digitizer. Okay. So these are the representing of the digital images. These are very helpful for the zooming and shrinkage. So for the zooming and shrinking of the digital images, for the zooming and shrinking, we are taking oversampling method. We are taking oversampling method. So that is oversampling means I'm taking the scaling function. So scaling algorithm I'm using for the oversampling. So sampling and quantization is the important rule for the zooming and shrinking. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.